we're just going to revise for your final. That can be anything from help me with a homework question to go over a concept or whatever. So it's really you ask the questions. Hopefully you'll ask some at least, and I'll try and answer them as best I can. I think what I should do, just to start things off, is to give you a kind of big picture view of your final that's coming. And that might be helpful. So I'm assuming that you can all see, I hope at least, our Canvas page. Is that what you're looking at? Oh, good. Right, so in particular, I don't know if you've had the chance to look at this fella here. I've been busily working on this. I forgot to update it, but I will get it updated really soon. All the update is a couple of typos and some solutions to a couple of questions at the end. For whatever reason, I forgot to do them. So let's show you this guy and just talk about the big picture. Your exam, your final exam, is going to be on Tuesday. So this is really the last class day you get to see me. And it'll be a 3-hour exam starting at 5, finishing at 8. This you can get in Canvas, so if you don't want to write it down, that's fine. You can look it up again. You then have an extra 30 minutes to upload your working into Canvas. So what's going to happen is that nothing is in WebAssign, not like a midterm was. It's going to be a PDF. Now, the way that'll work is that you'll go into Canvas and just like WebAssign, you know how suddenly the test appears? Suddenly on Canvas, a PDF saying final exam will appear and you click on it. And you will do the working and you will write them down. And then you've got half an hour after 8 o'clock to take pictures and upload it as a PDF and send it back to Canvas. Now, this particular test is a practice one. And so it is a lot bigger than the real one. For instance, this question has 20 multiple choice. The real final only has 10. And this question, actually, I think it's slightly bigger than it looks right now. Go a bit further. It's a solutions, don't want that. Yeah, this question here has 26, something like 26, 27 questions, rather than 10. But this is just a resource for you. So it gives you examples of questions and solutions to those questions. So hopefully that's something that might be of use to you. Now, your final exam is worth 30% of your grade. That's a lot of money, right? A lot of points. And section 1 that I was talking about, 10 questions. Each of those questions are worth 5 points. And that'll get you 50 points out of your final. When you are doing your test, when you're doing your final exam, I do not need to see any working. In fact, I won't pay attention even if I do. You will write down on paper things like the answer to 1 is A, the answer to 2 is D, the answer to 3 is D again, the answer to 4 is A, and so on, right? And the answer to 10 is C. And that's all I will see. I won't see any working, don't need to see it. You just put it in. Then once you get to section 2, there's going to be 10 questions. And on average, they're worth 25 points. And that's where the other 250 points are. So you can see essentially every point, every 10 points is 1%. So you can imagine how you could calculate your grade just through that. Now, when you are finished your homework this Sunday, I will try and get to you as soon as I can, but it won't be until sometime in the middle of Monday, Monday 1 o'clock or something like that. I will send you an email out and it will tell you your grade. It will also tell you how many points you need to get in the final to pass, which is a 2.0, and how many points you need to get a 3.0, and for some of you, how many points to get a 4.0. So you've got a kind of goal for what to do in the final. Back to section 2 now, 10 questions. I need to see working, working, working. So you'll tell me it's question 1. You won't just tell me that the answer's 42. You'll do a whole load of working, and then it'll be equal to 42. If I do not see the working, you do not get the points. It's as short as that. Why? Well, I could go into Mathematica and type in a question, and the Mathematica will tell me the answer. I could cheat. Can't really cheat if you show me working, because then I know how you did it. Now, I said the average 25. Some questions are only worth 20. Quite a lot are 25, and some questions are worth 30. But they average out at 25. So they're multiples of 5. Are we clear on that? Do you know that? Do you understand so far anyway what the structure of your final is going to look like? Okay, so 300 points, 30% of your grade, that's how it's going to look. You get partial credit in section 2. You don't get any partial credit in section 1. So when you're doing multiple choice, it's either the right answer or it's the wrong one, because there's only one correct answer. If you think there's 2 correct answers, throw a coin in there and pick one. Because if you write down both, that doesn't work. So you got to pick the one you think's most likely. There should only be one correct answer in every case. If by some mistake by me, I accidentally put 2 correct answers, which I will definitely not do, but I could, then everybody just gets the points for that question. Another thing about section 1 multiple choice, if it's going to take you longer than 5 minutes to get the answer, you're doing it wrong. Just pick C and move on, because all my multiple choice questions should be very quick, pretty straightforward, boom, 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 you got the answer. If you think, oh, I'm going to have to do this, and then I'm going to have to do a U sub, and then I'm going to have to do a whole load of algebra with trig, and then substitutes and blah, blah, and so on and so forth. If you kind of think that's how you're going to tackle a question, that's not the right way. Whatever you're doing isn't the right answer. So you just pick C and move on. You've got a 1 in 4 or 1 in 5 chance, depending on the question, of just guessing it right. And in multiple choice, since I don't see the working, if you are lucky enough to guess 1 or 2 right, then that's nice. It'll all average out in the end. That's about all I want to say so far. I've got a little bit more after this, but I'll pause. Are we comfortable with what I've said so far? You understand how things are going to work? We're good? Okay. So what's left? Your test will be in, fancy word, chronological order. You will have no numerical questions. So you won't get the trapezoid, you know, those left, right, Simpsons rule. They will not be in the test, except maybe a very minor one, which might say something like, which method would be the most efficient? And the answer is Simpson's rule, by the way. That means that the first questions you're likely to see are going to be things like integrate, right? Just basic integration. And the last question you're going to be looking at will be solving differential equations, right? Because isn't that the last thing we did? And so as it's like reading a book, you know, you page one, you did this, and page two, you did this. And as you go through the book, you get to the last page, and that's where the last questions are going to live. The test itself, the final exam itself, can't cover every topic. So half the things that you're going to study for will not appear in the final. Right? Half the exams that you have studied for will not appear in the final. So I'll make one off the top of my head because I'm making the final this weekend, so I haven't done anything yet. You study really, really hard to find surface areas, right? You're really good at it now. You've spent lots of practice. And guess what? I don't even ask you a question on it. That'll happen. So why? Well, I've only got 10 section 2 questions. If you look at all the things you've done, that isn't more than 10 things you've done. Volumes, shell and disk, two different kinds of differential equations, integrating, X subs, U subs, integration by parts, and just ranting on. I can't ask you every single one of those things, so I'm going to not ask some, and that's okay. So returning to that, half the things you're going to study for will not be in the test. Of course, Murphy's Law says the half you don't study for is the half that is in the test. So you got to make up your mind about how you're going to use your time. So that's something you're going to have to figure out, what you know and what you don't know, what you need to study a bit more, what you don't need to study much. And that is good. And that is everything I can think of to talk about in the final. But have I missed something or something you want me to clarify? This is your chance to ask. Any questions? Okay, I'm assuming that I did a pretty comprehensive job there. Right, you start the ball rolling. It's much better if you lot tell me a question than me just randomly pick things, because that's all I'm going to be able to do, is just randomly think of things. Any ideas? Any questions? I'm waiting.
In WebAssign, I was having trouble giving justifications for why I chose the direction field that I chose.
Ooh, is that the one where you pick the picture and then they give you like 4 or 5 sentences and you try and pick the right one?
Yeah.
Yeah. Is the reason you picked the particular field, I put it into some software and that's what I saw?
Yeah, and then it was asking for like the written explanation, and that's
Yeah.
where I was kind of lost.
Yeah, well, you didn't really do it by the written explanation, but I can pick one and kind of talk you through it if that would help. Do you want me to do that?
Yeah, that would help a lot. Thank you.
Okay, so let me just find. Off the top of your head, do you remember what section that was in? Just what number, so I can find it a little bit quicker. Because right now, I've got my usual 20 windows open. Was it introduction number 9.1? Was it later on than that?
It's 9.2.
9.2.
Yeah, 9.2.
I got you. Here we found it. Right, I had to go to another page to get that. I'll put that on the screen. I may have to go out and in to see this, but that's fine. I'm just scrolling down. I got you. All right, let's put the solution on that, make it easier. Scroll down, scroll up. How hard is it to find a damn thing? Okay. I'm scrolling by, I can't find one. I know they were there a minute ago. Oh, that's weird. WebAssign. Oh, of course, that's why. Right. Here's one. If I go out and in, we might get to see it. Right, so here is the differential equation. Y dashed equals 8 take away y. And you put it into WebAssign and you got this picture here, which is one that looks like that. You know, you put it into the software and you got that one. So that's not a biggie. Oh, by the way, if you're wondering what kind of question you would get in the test, it would be a multiple choice question, and it would be actually pick the right picture. That's all you would get. But let's look at their reason. And they say the slopes of each point are independent of x. So the slopes are the same along each line parallel to the x-axis. I know that for y equals, okay, let's turn that all into English and try and show you what they're saying. You look for features in the differential equation that give you some clues to what the vector or direction field would look like. Now, if you want to think of this as in English, the slope of each line, that's what y dashed is, it's a slope, is 8 take away y. Now, one of the things I can notice is that when y is equal to 8, won't the slope be 0? So when I am looking at my direction field, at y equals 8, no matter what the x value is, I want to find a whole load of horizontal lines, because horizontal lines is what a slope of 0 looks like. Are we cool with that? No arguments about that. Okay. Now, the second thing about this is that there are no x values. What that means is that when y is equal to any number you like, the x doesn't matter. So if I chose, for instance, a point like 7, right? Suppose I choose y equals 7. Then the slope will be equal to 8 take away 7, which is 1. So it means that 7, everybody, no matter what the x is sloping at 1. And if I choose a y value of 9, the slope is the y value, right? 8 take away the y value is -1, which means at y, it's going to slope down. And if you notice that every single one of them, it doesn't care what the x value is. When the y value is 9, it slopes down the way. And that's essentially why they picked the one that they picked. Now I'm going to return and show you the weird, almost like a lawyer way they phrased that. The slope of each point is independent of x. So the slopes are the same along each line parallel to the x-axis. That was that bit where I went, right? A whole horizontal low is all the same slope, and then a whole horizontal low is the same. That was what that was about. And when y equals 0, the slope was 0. And that was how they expected us to do that. In reality, the questions you're going to see will be multiple choice, pick that shape, and call it good. Did that help?
Yes, thank you.
Okay. I think the bottom line is don't worry so much about the written part, because that's not something you really should be tested on. There's so many different ways of describing it anyway, so I don't think it's really a fair question. Because you know, people see things differently, and so you describe them sometimes differently. But thank you, that was a good start to the day. Have we got another question now? Any questions? Your time is valuable. I guess I'll pick something while you're thinking about it. How about starting with a topic right at the beginning, and then just, going with it. That would probably be one of the easiest questions in the world, but I just want to get started. In a question like this, it's so simple, if it happened at all, it could be a multiple choice question, if it happened at all. Now, this guy is a power law. This guy is a standard integral, and so is this guy. What is the integral of sine x? It's a very simple question, but it might catch you out. What is the integral of sine x?
Cosine x?
Plus or minus?
Minus?
Correct. Now, that's the correct answer. Now, if this was a multiple choice, I might do that as choice B. If you're doing multiple choice, you have to make sure that one of your answers is the correct answer. But when you do multiple choice, the other answers shouldn't be just random things that you pick out of the middle of your brain and just write them down. They should all be mistakes or things that seem plausible. What do you think I did in B, which is wrong, but what do you think I did in B?
The derivative?
Right. Don't sometimes you forget you have your wrong hat on and you differentiate when you went to integrate? That's what that one is. I would hope you wouldn't make that mistake, but it does happen. Now, this one looks, oops, well, that is a mistake. Makes more sense to do that. What did you do? What did I deliberately do wrong? That should say cosine, by the way. What did I deliberately do wrong there?
Took the derivative of sine instead of the integral.
Right. Have you noticed that one of the hardest ones to remember when you do antiderivatives is the sine cosine pair, isn't it? Right. You're so good at remembering how to differentiate it. You're not so good very often at doing the antiderivative backwards, because that's what that one is. And this one here is some kind of weird monster that I can't think of why I picked it, except you added one by the power and then you divided by the 3. I guess, and again, we would do that, but I guess you could have. So if you are looking at multiple choice, that's the structure behind how it does. How's that going to affect you? Can you imagine you do a multiple choice question and you get an answer and it ends up being C? Your normal reaction is, good, I must have done it right because the answer is C. Couldn't it be, I got the question wrong, he just figured out how I did it wrong and put that as one of the choices? So when you're doing the question, you have to be very careful when you do multiple choice that just because your answer matches one of the four doesn't guarantee that it's correct. Of course, if your answer doesn't match one of the four, you are wrong. Okay, I'm looking for a suggestion, an idea, a topic. We got anything?
Can you go over 9.1 question 3?
Okay, I can do that. 913. Well, eventually I will, as I find the window. There we go. 913. Yeah, over here. Okay, we got it. Right, in question 913, again, WebAssign's being weird on me. Wrong WebAssign. Oh, wait. This is what I'm reading, but it looks weird. You're being asked to find for what values of k in y equals the cosine of kt is a solution to 81 second derivatives equals negative 25y. So this is the differential equation. This is going to be the solution. We're being asked to find for what specific values of k does this work. So obviously it doesn't work for every k. There must be some that it works for and others that it doesn't. So I'll start off with y is the cosine of kt. Then I'll find its derivative. So I've got my differentiation cap on. If you differentiate a cosine, you get a negative sine kt times another k. If you do the second derivative, you differentiate negative k sine t, you get negative k cosine kt times another k. So 81 second derivatives becomes 81 of these guys, and it's negative 25y becomes negative 25 of those guys. And this is negative 81 k squared cosine kt equals negative 25 cosine k. Then I'm essentially going to divide both sides by cosine k and kt. By cosine kt, and what that leaves me with is that this has to be true. If I divide both sides by negative 81, this has to be true. And if I take the square roots of both sides, I get plus or minus 5/9. So the values of k that they are looking for, and the only two values that work, are those two. So that's essentially it. Is that what you were looking for?
Yes, thank you.
Question like this, yeah, it could be multiple choice. It wasn't a short question, but as long as it takes less than 5 minutes, it's a candidate for multiple choice. It could also have been section 2, but if this was section 2, there'd probably be an A and a B, and that would make up the extra points. Any other questions? Okay, let me, oops, excuse me. Go away, go away. There we go. Let's show you a list of everything we've done. And that might help us a little bit. Jog our memory to things you might want to ask. Okay, so again, I hope you're all looking at the same thing I'm looking at, right? Areas and distances and numerical techniques are not going to be in the final. They are Simpson's rule and so on. And the definite integral would be like the integral of x cubed plus 5 sine x. And so 5(3), and so is 5(4). So those guys are really the beginning of doing various kinds of find integrals with numbers or without. Then a huge chunk of substitution, and then areas between, some volumes, work. Wasn't work pulling boxes up mountains and hills and buildings and leaky buckets and ropes. That's that one. Average value of a function. The technique called integration by parts. That's how you would integrate essentially a product. Trig integrals would be sine x cubed cosine squared, tan x secant squared, that kind of thing. X subs is what 7(3) is. Partial fractions, how to integrate fractions is 7(4). 7(6) isn't really a question, it's more optional, but that's using tables. Limits with infinity in them is 7(8). Then we did arc length and surface of revolution. And the last applications were center of mass and hydrostatic pressure. And then we did the differential equations, variable separable. Didn't do that one because it's optional, and we finished with linear differential equations. Right, now I've got that basic list in front of you. Does that jog anything that you say, oh yeah, it's been a while since I've done that, I forgot about that, and then you want me to do? I'm not sure if that's a good sign or a bad sign. Does that mean that you're comfortable and you're really nothing in particular that's bothering you? Or you're too shy to ask? Remember, if you ask a question, there's 10 other people who wish they had the same answer, but they're just too shy to ask. So you're not just doing it for yourself, you are doing it for others.
Could we go over question 1 on the practice exam?
Oh, I wasn't expecting that. Of course we can. Are we talking question 1 multiple choice or question 1 section 2?
Yeah, the multiple choice. It's been
Okay.
a while since I have looked at the strips.
Right. Now, oh, you're right. Question 1, we could certainly go over, but can I tell you that question 1 is not going to be in the final, so I won't go over it. But I'll tell you how you would have done it. Right. You would have done left 4 or right 4 or trapezium 4 or Simpson's 4, and it would have been one of these numbers, and you would have picked it. So you remember where you do delta x, which in this case would be 1. So that's really easy. X equals 1, 2, 3, 4, and then you would evaluate the function at those. And then if you're doing the left 4 or the right 4 or the midpoint 4, you plug them all into a big number crunching equation, and you get your answer.
Okay, now that I remember that, thank you.
Yeah, but you're not going to get that in the test. I've already given you tons of homework questions on that. They take forever in a day, and I've got so many things I want to ask you. I don't want to use one of my section 2 questions, especially on something as mundane as that. Okay, but it was a good question to ask. So some people are going to look at that and think, hey, he said there's not doing it, and then he did one. You're right, I did do one, but I'm not going to change it now. It still won't be in the final. I mean, your time is valuable, and I don't want to just hang about here and bore the hind legs off you just because, you know, we're here, and you'd much rather be, you know, doing your homework and getting ready for the final. I really don't want to do that to you because your time is valuable, and I don't want to just do busy work. So I'm going to tell you a joke to try and give you a chance to relax, and then maybe after this joke, you will ask me questions so I stop telling you jokes, right? So we're going for that one. I was told by someone in my Calc 4 class that today is Speak Like a Pirate Day. Did you know that? That meant to be true. You may have been pulling my leg, but that's meant to be true. And when he told me that, it reminded me of some jokes. So pirate jokes coming up. What is a pirate's favorite letter?
R.
You would think so, but actually their favorite letter, their favorite love has always been the C. The C. Oh, thank you. I got 3 responses to that one. Think about it, the C. Okay. This little boy, tiny little kid, was totally fascinated by pirates. You know how like some kids are dinosaur people, right? And some are superheroes and whatever. This kid desperately loved pirates. And he was out one day by the beach and he saw in the distance a pirate, a real movie kind of pirate, right? Real life pirate, not a pretend one. Everything just like you'd expect. Peg leg, parrot in the shoulder patch, hook, dressed in the pirate gear, you know, the long john silver stuff. Cast iron, perfect. And the little kid freaked out. And he ran away from his mum and he runs over to the guy and he looks at me and says, "Are you a real pirate?" And he goes, "Ah," he says, "I'm a real pirate." And the little kid says, "Oh, cool." And the little kid looks at him and he says, "How come you have only got one leg? How come you've got a wooden leg?" And the pirate says, "Well, I was out at sea one day and there was a big battle and a cannonball, it blew my leg off and I got a peg leg." And the little kid went, "Wow, that's cool." The little kid looks at him again. He says, "How come you've only got one hand? How come you got a hook?" And the pirate says, "Well, I was out at sea one day and there was a big battle and a cannonball, it blew my hand off and I got hooked." The little kid went, "Wow, that's cool." And the little kid looked at him again and he says, "How come you've only got one eye? How come you got a patch?" And the pirate says, "Well, I was out at sea one day and a seagull pooped in it." And the little kid says, "You don't lose your eye just because a seagull pooped in it." And the pirate said, "You do when you forget you've got a hook." Oh God, I don't know if you could see the reactions I've got. Ryan, what does that reaction mean? Don't know if you can speak, but he gave me a face with an open circle mouth, a solid circle mouth. That one, yeah. What does that mean, Ryan? Oh, it's the same as it's very funny. Okay. Has anybody got any pirate jokes for us? Or any jokes then? Oh, come here, boy. Come here. Up, easy. Up, up. Hi, everybody. This little guy is called Bailey. Yes? Oh, thank you. Bailey is a snuggle bug. He is a Westie, and I guess no, only one. And he's our little fur baby. He's missing his little sister. But as you may notice, the minute you put him on this, he goes into, oh, he's not, he's went away. Okay. Oh, I'm sorry. There we go. He normally goes into sleep mode. When I pick him up, his head goes over and he goes to sleep, but he's interested in something. So I think he wants me to do a poo walk. Not that we can do that right now. Sarah, are you laughing after you've got that joke? Because that was 5 minutes ago.
No, I'm laughing at you.
I don't know how to take that one. You're laughing at me in a nice way, I'm assuming.
I was.
Okay, he's gone. Right. What? Shall we just call it a day? Because I really just feel I'm hanging on you, and you've got nothing you want me to do, and I don't want to do that if there isn't anything I can help you with. Okay.
Good question in the chat.
Oh, perfect. Thank you. I can't see the chat. Let me have a look at it. It's in another window. No, still can't see it. Can you read it to me? Or roughly, what does it say?
Can we do a problem like question 22 on the practice exam?
Okay, 22. Is it section 1 or section 2? Whoever asked that question? Just finding. Oh, wait a minute. It has to be section 2 because there isn't any 22 in section 1. So that's I've answered my own question. Okay, I will do it. Oh, we want a leaky bucket of water, do we? Right, let's do leaky bucket of water questions as soon as I figure out how to get my screen back. It's under advanced and it goes there. Okay, the ultimate version of the leaky bucket water story will have some building or hole in the ground, it doesn't matter, and we'll make this distance here 60 feet. And they have a rope. Well, they have a little guy. Here he is. And he is lifting a bucket with a hole in it. And the question tends to be, what is the work done in lifting this bucket of water from the bottom to the top? And you're given some other information. You'll be given, for instance, the weight of the bucket, which I'm going to say is 5 pounds. The weight of the water in the bucket, at least when it was full, we'll make that 20 pounds. And the rope can weigh, it's always in terms of feet, so the rope can weigh ½ pound per foot. Now, since these units are in foot and pounds, we don't need to do anything else. If these units were kilograms and meters, we'd have to multiply by a really annoying number. Can you remember what that really annoying number is? Meters and kilograms. What's the metric number that kind of appears when you do meters and kilograms in anything metric?
9.8.
Yeah, so there'd be a 9.8 involved. But if that was the case, you'd be told about it, right? So the work done is essentially the integral from A to B of what I call the force function. Now, there are lots of different versions of how to do this, and that's one of the problems that might have happened in WebAssign is that if you count X from the bottom or the top and things like that, you get different looking answers. The final number's the same, but the working's not the same. In particular, the f of X looks different, and that causes all sorts of problems. It doesn't in the final, because I don't care how you measured x, because it'll still be correct. So what you do is that you decide to pick a random position on the journey from the bottom to the top, which is this position here. And I like, in these questions, to make that distance x. And so when I find f of x, I'm basically looking for the weight of everything at that position. And what does everything look like? Well, it's going to be the weight of the rope at that position, the weight of the bucket at that position, and the weight of the water. And I forgot to mention something. In this story, the water that's leaking out leaks out in such a way that when it reaches the top, it's empty. So that 20 pounds of water slowly leaks out so that when it reaches the top, it's going to be empty. So we have a little side question to do with the water, but let's do the straightforward ones first. Because I'm measuring x this way, at this position, won't there be x feet of rope? And if every foot of rope weighs a half a pound, the rope will be a half x, right? So if you had 10 feet of rope, it'd be half 10. If you had 50 feet of rope, it'd be half 10. The bucket is going to weigh 5 pounds no matter where it is in the journey. And the water, well, I haven't done the water yet, because that's going to be the hard part, getting the water right. So first thing I'm going to calculate is the rate at which you lose the water, which is how much do you lose every foot as you go up? And it's not as hard as you think. There are 20 pounds of water leaking out over 60 feet. Do you see that ends up being 1/3 of a pound per foot? Are you happy where that 1/3 of a pound per foot for the leaking water comes out? Okay, now it gets a bit messier. I need to know that distance. This is 60 feet and this is position x. So this distance is 60 takeaway x. Why is that important? Because isn't that how much water you're going to lose? Whatever that distance is, times 1/3 is the water. So how much water do you lose? Right? Well, you're going to lose 1/3 that distance, which means 20 take away 1/3 x. So this gets kind of convoluted, but eventually it's going to come back. So if I know how much water I've lost, I guess I'll call it lost, how much water is left? Well, you started with 20 pounds and you lose that much. So at position X, you get that. 20 take away 20 cancels out, take away that's 1/3. And it looks kind of too simple to be true, doesn't it? But it is true. So this here is 1/3 x. So what do we get? If we add that and that, you just have to trust me, you get 5, 6x plus 5. And now we have the force function. And so the work done is the integral from a to b of the force function dx, which is going to be the integral from 0 to 60. And the force function is that. And this gets me add 1 to the power, divide by the new power. And you evaluate that at 0 to 60. What does that look like? 5/3 times 60 squared plus 5 lots of 60 take away a whole load of nothings. And if I do 5 times 60 squared divided by 3 and then take away 50, no, add I should say, add 50 times 60, I get the answer 9,000. And if you want to know the units, they're footprints. Okay. Are we comfortable? Probably draw this down a little bit. Something like that. Are we comfortable about how we organised this question? We created it, right? So let me talk you through partial credit. Let's just say, for argument's sake, that you got this question. And you're pretty sure you knew that, right? You figured that out, you got the rope, oh, that's great. But you couldn't really figure out this piece. Now, it might be you don't even know where to start, right? You just haven't a clue how it's going to work. You might just say, well, that's the end of the question, and you stop there. You're saying, look, if I can't figure out who this is, I know I need to know what this is, right, at position X, but it's gone. I haven't an idea. What do you do? Well, if you stop there, you will get quite a few points, but you won't get that many because there's a lot still to do, including this bit, right? So what you do is you guess. I know that's not good, and you probably don't like it. But I mean, don't pick something weird like e to the x plus 99. Just pick something like 2x or 47 or 20. Just pick some. Will it be wrong? Yes. But won't that be the only piece of this puzzle that's wrong? Won't you do this correct according to your answer? Won't you then be able to do this? And then you'll get an answer. Now, what that allows me to do is I can give you a lot of partial credit in this question. Because if you think about the entire process, isn't the only piece of the process that you were missing was you don't know how to find what the weight of the water would be at a random position X. So if this question was worth 25, you'd lose 5 points because it is important. But the good news is you get 20 points because the rest is correct. If, however, you stopped here, you'd only get 10 points. So can you see that it is possible to double the number of points by continuing the process? So I want you to think of that as a general thing. Whenever I'm doing an integral or whatever it is I'm trying to solve, if I get to a place where I need something, I need to know something, but you can't figure it out. Maybe you can't figure out where the start and finish limits are. Then make some up, right? 0 to 10. Just so you can continue the process, right? Imagine you're doing a differential equation, changing the topic, and you don't know how to finish off the integral part, right? You do some integration, right, the integrating factor, and you can't figure out how to finish off the integration part. Couldn't you just make up an answer for the answer? Just fill in the gap with something, and then get the answer, because that would allow you to do the y of 0 part. So we'll try and put some meat on that. Imagine you had a linear differential equation. Something like that, right? And you got to the part where the solution was this fella. And you get an integral, and it ends up being x sine x. Right? But you don't know how to do that. you've forgotten that it's an integration by parts. You will do this. Well, let's pretend that's this sin x. You will simply just do this. I don't know, that looks to me like it would be an x squared cos x, because I want it to be. That's wrong, totally agree. But don't you very often get questions where y of 0 is 7? Now I've got an answer, can't I use that to find out the c? What that allows me to do is it allows me to continue the process. Actually, I better put something like pi over 2 here, right? And I can find c. Now I can find c for the wrong question, but that doesn't lose you points. You only lose points once. You lose it when you didn't do that. But whatever you write here, I will use that as what you should do from that point onwards. And that will be treated as if it had been true. Because if it had been true, you would have done the right thing after that anyway. So you're able to show me the process. So always think about if there's something missing, guess and fill it in so you can keep the process going. Does that help? Okay, so you're always on the hunt for points. While I'm nattering on about strategies, when you do a final, if you come across a question that you just don't like and you've always had problems with it, like I'm never any good at those buckets getting pulled up mountains, I just don't know what the heck I'm doing, you will leave that question and you will do every other question first. And once you've done everything that you possibly can do, then you can go back and have a look at it and make your best attempt at filling in as much as you can. And the bits you don't know, you guess and you fill them in anyway, and then you just keep going. Okay, you'll never get full points doing that, but won't you get more than 0, which is kind of what you would have done anyway. Right, I'm ready for another question. Have we got one?
Can we do an integration by parts question where you have to do multiple integration by parts?
Yes. So let's do an example of that. Let's see if I can make this happen. So the question was integration by parts in a situation where you have to do it more than once. So how about x squared e to the 3x dx? That would be an example of integration by parts. Now, side issue. What would that question be? How would you find that answer?
Substitution.
Use up, right? So, you see how similar? But integration by parts is correct. So I'll make that f and I'll make that j. And the formula for integration by parts is this one. For the benefit of the rest of the class, what are the kind of rules about what you pick for f and g? Why did I choose these two? Could I switch places? Well, the answer is no. It wouldn't have worked if I'd made this f and that j. So what was the idea behind picking it this way and not the other way? What happens to this fella when you differentiate him? By the way, that's an if dash. Doesn't he get simpler? That's why I picked it. So if you're looking at that as a choice, that's very often a good reason to do it. So what it is this guy. If you integrate e to the 3x, you get an extra 1/3. I hope you're happy with that. The derivative is 2x, and you integrate the e to the 3x, you get that guy again, dx. And so we are looking at 1/3 x squared e to the 3x, take away the integral 2/3 x e to the 3x. Except we have to do another integration by parts. So it's going to be equal to all of this again. Yeah, there's a couple of ways of dealing with this negative. If I put a negative here, won't I better put brackets around to make sure I don't screw up? Because one of the things that I tend to do when I do integration by parts is I sometimes lose signs. So I'm taking away the answer to this. So I'm taking away the answer to this. Leave the first guy alone. It's 2/3 x. Integrate this guy, you get him yet again. Differentiate this guy, you get 2/3. Integrate him, you get that again. Now you get this fella. Take away this fella, and while I'm at it, I'll multiply them together. Take away this fella, and while I'm at it, I'll multiply again. Now, do you see the advantage of sticking a bracket in the minus now that I know I've got these correct? Well, almost done. If you integrate this, you get 1/3 e to the 3x. 1/3 times 2/9 gets you 2/27 e to the 3x, and then you can finish with the plus c. Are we cool with that question? Since we're on integration by parts, let's do special case. Whenever you see an integral with a log in it, and it looks maybe something like these guys, and you know it's an integration by parts, because sometimes I just tell you, I will say, use integration by parts to find this integral. And if I say use integration by parts, it is not a suggestion, it's an instruction. Secondly, it's probably because that's the only good way of doing this question, so you don't end up going, a rabbit hole and getting lost. But in each of these special cases, if it is going to be integration by parts, we have to figure out who the f and who the g are. Now, in this one, you add an extra 1. Which one of these two guys is going to be the f of x? The log or the 1?
The 1.
So you're going to make him f, and you're going to make him g. Right, if you did it that way, won't you have to integrate the log? Can you see why that doesn't work? Because we don't know the integral of log unless you've wrote it down earlier. So, see about the special case. When you see logs, all bets are off. In this one here, make that the f, make this the g. In this one here, make that the f, make the g. So if you ever see a log integral and it's integration by parts, the piece that is the log, right, whatever that log is, will you make that the f, and the other thing, whatever that is, will probably be an x or a 1, an x squared. Make that your g. Now, if you'd started that, you would eventually figure out probably around about here. Oh, wait a minute, that's not going to work. And well, just return back to the drawing board and switch them. Have you ever done a U-sub question where the U-sub you picked didn't work? There was an orphan X left over that you couldn't figure out how to turn it into a U because it wasn't possible. Well, when that kind of thing happens and you know it's a U-sub question, don't you just go back and find a different U-sub? And hopefully the second one works. Okay, that was a good question. I like that question. Oh, we got another one. Okay, while you're thinking about that, contacting me before the final. Since I don't get you on Monday, if you shoot me an email, the earlier the better. I've got some business, as everybody has over the weekends, but I will drop in from time to time. We can figure out a time, and if I need to, I'll do a Zoom meeting for you. If not, I'll try and answer your question through email, which is typically quite hard for math questions, but if it's possible, I will do it. So that's how you're going to contact me. On the day of the final, which is Tuesday, for our class, that is a horrendous day for me. I know it's a horrendous day for you, but by some brilliant scheduling, I have 3 finals, all 3 hours, all on Tuesday. So I'm pretty much going to be unavailable on the day of the final. You probably will be able to catch me just before our final exam finishes, because I do have a couple of hours between, I think from 3 to 5, where I don't have an exam on, but I'll be solid exams up to then. So if you need to catch me, that'll be a bit late, but better late than never. I can do that as well. So contact me by email and I'll try and figure out a time. And I've done it before, so don't feel bad about it. Sometimes it ends up being Sunday at 1 o'clock, right? We just do a Zoom meeting whenever it suits you and it suits my schedule. That's about all I can think of. And
Will we still be able to use notes and Desmos and stuff like that?
Good question. Yes, I forgot. I like people to ask me questions like that. When you turn up on the day of the final, so up to Monday, everything will be available. But once Tuesday morning starts, I will go in and you will be locked out of everything on WebAssign. So you won't be able to go there because some of the exam questions will probably be similar to those. And it's not really a good idea for me to do that because then you could just go in and see what the answers were and copy them. And so that'll be locked out. But what won't be locked out, you will be able to get a formula sheet, which I'll put in Canvas. You'll be able to use Desmos and the software that we use to do the vector fields, all those things, the direction fields, another name for them. That'll be available. The sheet that's got all the standard integrals in will be available to you. And the only other things that will be there then will be the final itself and a place in Canvas for you to upload your working once you've finished the final. So everything else in Canvas will disappear as well. Now your question was, can we use notes? You can use notes. You can use anything that's physically written down. You are not allowed to, just like in the midterm, do any interactions. So you can't go to tutoring sites, you can't use computer software, because that's really interaction as well, and you can't phone a friend. There will be a Zoom meeting during that final, so I'll have to see you all to make sure your big brother's not helping you. But you might want to think seriously about writing down everything that you know, or printing it out if you've got a printer, of everything that you would like to have handy. I would, for instance, would definitely do a much neater version of, let me show you this guy, of that guy, right? I would also do another version of every trig identity that I think I might need or use. You don't need to worry about the formulas themselves, you know, like the integration by parts formula. They're not that many. Or the integrating factor when you do linear differential equations. There is a formula sheet that I give for that.